Hello calculus student, this video is for chapter 4.3 part 2. So in part 1 we learn about absolute maximum, absolute minimum. We learn about some theorem that guarantee that there is a absolute max and absolute min. That means the highest point, highest function value in a closed interval if f of x is continuous. And so we also look at how can we find them. So let's briefly just review where can those absolute max and min could be. So these are all possible value of functions where f prime of c is 0. So these are all critical points. F of c is undefined. F of c equal to 0. So it's 0 because your tangent line slope is 0. So there's two cases. Well, the tangent line slope could be 0 because you are increasing and then you stop to increase and then you increase again. Or you can turn. Okay, so f prime of c equal to 0 does not mean that it is absolutely a maximum or a local a maximum at all. It could be that it's not. But you would have a maximum if f prime of c is undefined because you have a cusp or a corner. So this is also an undefined case where it is not a maximum. So these critical points, so all these are called critical points. Sometimes, so in this case, and this case, and also the lower case, the one where you have like being the lowest point in the parabola, are all potential absolute maximum and minimum, but they may not. So that's why when you find the in order to find them, you actually have to find all of them and try to figure out which one is by comparing all the different ones with the endpoint. So let's do an example. So I have a function 3x to the fourth minus 4x cubed. I want to find the absolute extrema. That means I want to find the absolute max and min. And this is a closed interval, and this function is continuous, is polynomial. So we know that we guarantee to have one maximum and one absolute minimum. So how do I find it? First is to find the critical points. So they may not be, but if it is absolute max and min, they must be a critical point. So we find all of the critical points first by solving f prime of x equal to 0. So find f prime of x will be equal to 12x to the cube minus 12x squared. Okay, so solve critical point. So it would be solve 12x cubed minus 12x squared equal to 0. Common factor is 12x squared, x minus 1. So when it is equal to 0, x equal to 0, when 12x squared equal to 0, that means x is equal to 0 or x equal to 1. So that we have two critical points. And then we have two endpoints, negative 1 and 2. These two numbers are between them, right? 0 is between them, 1 is between them. So we'll build a table and we'll just use decimal to build. X is the lowest, is negative 1, and then we just 0, 1, 2. And then f of x would be our 3x4 minus 4x cubed. So remember, the f of x is really the f of x, not f prime. F prime is to find the critical point. So these are critical point that could be the maximum or minimum, but not necessarily. Critical point. Some other book call it critical numbers. So let's use our decimal. You can also do it with, just delete all these. Maybe I'll just do a new graph. Okay, so let's delete all these first. Don't need them anymore. Okay, what was our function? Our function is f of x equal to 4x to the cube, right? Was it 4? No, 3x to the fourth minus 4x to the cube. 3x to the fourth minus 4x to the cube. Okay. And then we just do the table. In our case, our boundary is -1 to 2, with 0 and 1 being the critical point. So it'll be -1, 0, 1, 2. Okay, so it is 7, 0, -1, 16. So put it back here. 7, 0, -1, 16. So what is the highest f of x in this interval? This is the highest. So that's absolute max is 16. What's the lowest one? This is the lowest one. Absolute mean. So in this case, this critical number 0 is not anything. It's maybe just local. This is the endpoint, but it's not the absolute highest or lowest. But these two are. Let's do it another one. So that's what it is. Okay, and maybe in the next one I'll do the calculator. So let's see. First of all, we find a critical point. In the book, they say find f of 1 and f of 3 first, but we can find them after we find all the critical points. So what is f prime of x? 2x is 2 minus 3 times 2/3 is times 2/3 times x to the -1/3, right? So f prime of x would equal to simplify it, 2 minus 2 over cube root. So now, what is the undefined point? Oh, last time I didn't ask myself if there's any undefined. Undefined, it is 0, x equal to 0, because you cannot divide by 0. What about f prime equal to 0? Critical point is when it is either undefined or this is equal to 0. So you solve 2 minus 2 cube root of x equal to 0. So it would only be if 2 is equal to 2 over cube root. Oh no, cube root here. So I do the cube on both sides. Well, actually, it would be 1 equal to 1 over cube root. So it would only be possible if, because x cannot be 0, so I can multiply it on both sides. It's equal to 1, so what would it be? X is equal to 1. So I have 0 and 1 being the critical point. So our x is the boundary, -1, 3, -1, 3. The two numbers in between is 0 and 1. So let's use a calculator to do, what is it? 2x minus, oh gosh, I need to write down. Can't remember that. Is 2x minus 3x 2/3. So maybe I'll try to show it to you with instead of this, we can use calculator on, clear it first. So y equal, clear this, but 2x minus 3x to the, oh no, gosh, 2, okay, I have to use the x minus, it's better to use it here, x to the 3, 2 divided by 3. Okay, so this is our function, and then how do I do table? So you have to do table set as, and then second table, and then you can delete all these, delete. We were doing what, -3, is it? -3? I forgot. Oh, -1013. -1, oopsie, gosh. -1, 0, 1, 3. So put it here. So -1 and 3 are the two boundary point, and then 0 and 1 are the middle number. So what is the highest? The highest is 3.9199. No, let's write it down. Copy it to our -3, 0, 1, 3.9199. Okay, put it back. f of x -3, 0, 1, 3.9199. So this is the highest, right? So the absolute max is f of 3 equal to 3.9199. Absolute mean, because it's a closed interval, right? It's the lowest is 3. F of -1 at the endpoint -3. So that's basically how you do. Okay, do one more. This is f of x equal to x over 100 on 0, 100. Closed interval, is this continuous? You have to make sure that it's continuous. Where is it not continuous? It's not continuous at x equal to -1, which is outside this domain. So we are safe. Where it's only negative at -1 is not continuous. So it's make sure that you have absolute max and min. So find critical point. So to find critical point, we will have to do a prime of x. Oh, this is a quotient rule. Fake and GIF, right? Fake and GIF. So we say fake minus GIF. Fake means do a derivative of this is 1 times 1 plus x minus GIF is the derivative of this times this is minus 1 times x. Oh, that is equal to 1 over 1 plus x square. Okay, so let's figure it out. F prime of x is equal to 0 at the critical point. So, is there any undefined first? So there's no solution because you can have 1 over 1 plus x squared equal to 0, right? There's no solution. But what is undefined? Undefined at x equal to -1. So this is the only critical point, right? Now we are to build a table. X, do I have to put -1? No. Why? Because it's not in 0 to 100. So all we need to do is just do 0 and 100, and there is no f prime equal to 0, so no solution. So, and then I'll do f of x. I can actually do it by hand. 0 over 100 is 0. 100 over 101. Of course, this is the maximum, absolute max, and this is the absolute mean. Okay, so there are cases where your critical point actually is not in the interval, and you don't need to take care of it. And as a matter of fact, x equal to -1 is the discontinuous point. Okay, the last one, find the absolute extrema for f of x, g of x minus x on -5, 2. Again, is this continuous? Yes, this is continuous. This is continuous. There's no discontinuity, and then -5 over 2 is a closed interval, so that should be 1. So first of all, find f prime of x because we want to find critical point. That would be e of x minus 1, right? So undefined, none, right? Undefined for here is none. What about solve equal to 0, minus 1 equal to 0? That means e of x equal to 1. So what is x? X is equal to ln 1. ln 1. Because if you do ln on both sides, so that would be x, right? ln 1. So we have a table of x, which is -5. ln 1, is it greater than 2 or less than 2? I don't know. ln 1 is 0, right? ln 1 is 0. So 0 is in between it, -5 and 2. So we put it here. And this is our f of x, e of x minus x. So I'm going to just use decimal to do. It's a little faster. E of x minus x. And what number do I need? -5, 0, and 2. -5, 0, and 2. So it's 5.01, 5.38. So obviously 5.01 5.38. This is